Hi everyone, I am Paula Seves from Ateneo de Zamboanga University in the Mathematics Department, College of Science and Information Technology. Today I will be showing to you on how we use the Microsoft Excel as an alternative for data analysis for statistics. If you don't have your PSS, SAS, or other statistical softwares, the best alternative is actually the Microsoft Excel. But before we are going to use your Microsoft Excel, try to look into the data. Okay, click the data here, then try to observe if the data analysis tool is activated. But just in case it is not activated, I want you to go to File, then you click Options here. Then after clicking the options, I want you to go to Add-ins, and then if your analysis toolpath is not activated, you click this, and then you may find this in inactive application add-ins. No? In my case, it is already activated, so you can see this in my application add-ins. You click this, then you go to Manage, you click Excel add-ins. Then you click this, then click Go. Then after that, you click Analysis Toolpath and Analysis Toolpath VBA. Then you click OK. And then when you try to look into your data, you notice that your data analysis tool is already activated. Okay, so I guess everyone is prepared now how to use the data analysis tools. Now, in this case, you notice that we have a data here. The data here is all about the employees of the Zamboanga city. We have the sex here, the age, the college or universities they graduated, years in service, and the salary. Now we would like to look into the summary statistics of the age. So what we're going to do, you go to click data analysis, and then you observe that there is a series of statistical tools. No? But in this case, you click descriptive statistic, and then what you're going to do, you click input range, then you highlight the data in the age. Okay, highlight this. Then there you are. Afterwards, you go to the output range. Then you click in the area that where you want to put the summary of your statistics. In this case, I would like to click it here as my output range. And then you click the summary, okay? And then you also click the Kate largest and the Kate smallest. But the summary of statistics, the smallest and the largest data is already given. No? What you're going to do, you click this, and then you click to, meaning to say that after this, you will see the second largest and the second smallest data. You click this one, and then there you are. We already have the summary of the statistics. Okay, so let's say we have summary statistics. And then you notice that we have the measures of center tendency, which is the mean. We also have the median and the mode. These are given in the summary statistics. And then let's try to highlight this. There you are. And then this is summary statistics. And then the measures of variation is also given. No? The standard deviation, the variance or sample variance, and the range. No? These are actually the measures of variation. Then we try to also highlight this. So this is to show to you that the color indications here are actually for the measures of central location, and the other one, the yellow color, is for the measures of variation. We also have the kurtosis and the skewness. And the minimum value is given, which is 23. The maximum value is 62. And the second largest value of the ages here is 61. And the second smallest is 24. And then you notice that we don't have our coefficient of variation here. So we are going to use the Microsoft Excel formula to compute the coefficient of variation. Okay. There you are, coefficient of variation. Okay, so there you are. So this is how we are going to compute for the coefficient of variation. You write equal, and then we know that the formula here is the standard deviation divided by the mean. And then you enter. Then there you are, you have 0.29. Since the coefficient of variation expressed in terms of percent, you click percent here. There you are. So the coefficient of variation of the ages of the employees here is actually 29%. Okay, so there you are, no? Now what's the next thing that we're going to do, no? The measures of central location is given. The measures of variation is also given to compute the measures of position here. What we have here, we are going to find out or use the percentile. Okay, so let's say we would like to find out the 10th percentile. Let's say the 20th percentile. Let's say the 25th percentile. Then let's say we have the 40th percentile. And then after that, we are going to write the percent equivalent of this. No, 10% for the 10th percentile. Then we have the 20% for the 20th percentile. We are going to use this percent to compute our percentile. Now, what we're going to do here, okay? Now you observe that the 25th percentile is the same with the first quartile. The 50th percentile is also the same with the median. And the 75th percentile is also the same with the third quartile. Then we are going to compute this later if they have the same output. Now, what we're going to do here, you write equal, then you type percentile. Okay, there you are. And then are going to highlight the data in the pages. Okay. And then go to function F4 for the absolute reference. Okay, there you are. If you have your dollar signs, no, this is what we call the absolute reference. There you are. Then after that, you click 10%, then close parentheses, then enter. So we have now 26. What do you mean by this? This means that 10% of the employees is actually below 26 years old. Okay, so let's try to drag this down. Okay. Okay, so there you are. So 20th percentile is 28 years old. I mean, this is 28 years old. So what do you mean by this? That there are 20% of the employees are actually below 28 years old. 25% of the employees is below 30 years old. Then 40% of the employees is below 36 years old. 50% of the employees below 42 years old. 60% of the employees below 45 years old. 75% of the employees below 54 years old. 85% of the employees below 56 years old. 90% of the employees below 59 years old. 95% of the employees below 61 years old. And 99% of the employees below 61.6 years old. So this is how we interpret for the percentile. Now let us try to go to the quartile. We know that the 25th percentile is also the first quartile. The 50th percentile is also the second quartile or the median. And the 75th percentile is also the third quartile. You notice that the 50th percentile or the second quartile is actually equals to 42, which is the same. No? The median is also 42 because 50th percentile and the second quartile is actually the median. Now, let us try to compute um, the quartiles here. Now, write equality, type quartile, and then click this, and then highlight the ages. There you are. And then type comma, and then click this one, the 25th percentile, then there you are, 30. So the 25th percentile and the first quartile is equal to 30. Let's try to uh, solve for the second quartile. Then there you are, double click, and then highlight. Maybe you can use the what we call the absolute reference, and then we go to the second quartile and click it. So 42, and this is the same, no? And let's say to have the third quartile, and then okay, it must be quartile, and then we go to ages, and then there you are. Then you have the third quartile. Okay, so this only shows that the 25th percentile is the same with the first quartile, the 50th percentile is the same with the second quartile, or the median, then the 75th percentile is the same as the third quartile. We are going to highlight this just to show the same. So let me move it here. Maybe I can have this. And then the next one, this, and the 75th percentile. We also have, okay, so there you are.